Do you feel the vibes?
So back when we first talked about inverses, when we were doing, quadratic equations and so on, we said that before we could find the inverse, right, of something, we said first we had to make sure that it passed the horizontal line test. Because if it didn't pass the horizontal line test, then its inverse wouldn't be a function. So for example, if you have a parabola like this, this does not pass the horizontal line test. Meaning, if I graph the inverse of it, the inverse will not be a function, right? However, if I only take one part of the parabola, if I restrict the domain, and if I only take that one part of the parabola, that does pass the horizontal line test. And if I graph that function's inverse, that will be a function as well. Okay? So, so now, okay, well, when we get to like a sine function or a cosine function, well, then at first it seems like there is no hope, because if you look at a sine function, right, it keeps going and going and going. When we first graphed sine and cosine functions, we only started from 0 and went to 2 pi, but that continues forever. So you could also have the part of it in the negative x-axis, right, negative 0 to negative pi to negative 2 pi and so on. So that does not look like it passes the horizontal line test, which means, do we just abandon finding an inverse for it? No, we have to restrict the domain so that we only take a portion of it that does pass the horizontal line test. And for the sine, it could be any portion really, but what we do is we take this portion, right? So it goes from, one part of it's just like around the origin. So that part, if we just center on that part, it does pass the horizontal line test, and we will be able to find the inverse for it. So now, let's see what the restricted domain of this is, right? So on this end to the right, this is pi over 2, right? It's halfway between 0 and pi. And then on the left, it's negative pi over 2. So if I just cut the domain and go from negative pi over 2 to pi over 2, then that's a good enough portion for me to find an inverse. Anything else, right, from here just completely drops out. So when we're doing this, we're not going to use any of the angles that are outside of that region. Okay? So, so what did we do then? We restricted the domain to the interval negative pi over 2 to pi over 2. And then the restricted function will have a range from negative 1 to 1. Okay, so when you find the inverse of this, if the function is sine, the inverse of this is the inverse sine function, and it's written like this. We've used inverse sine before to find angles, right? Mm-hmm. So this is now like an actual formal function for it. It has a synonym. The synonym is arcsine. So you can either write y equals inverse sine of x, or you can write y equals arcsine of x, and they're synonyms. Those two are interchangeable. Okay? So we read it as y equals, the inverse sine at x, and so on. Now, let's talk about domain and range. So we have f of x, and we have inverse of f. Okay? When we first learned about inverses, we said you find an inverse by switching x and y, correct? Okay. So when you switch x and y, everything associated with the x swaps with everything associated with the y. So the domain and range will also switch. So now we said the domain of the restricted f of x is from negative pi over 2 to pi over 2. And then the range is from negative 1 to 1. Yes? Now, for f inverse, for inverse sine of x, this is going to switch. So the domain will become the range, negative pi over 2 to pi over 2. And the range will become the domain, negative 1 to x to 1. All right? So now, look at the graph of sine of x. The horizontal axis goes from negative pi over 2 to pi over 2. Vertical from negative 1 to 1. If I graph the inverse of that, it looks like this. Now, let's take a look. Negative pi over 2 to pi over 2, that's now on the y-axis. Negative 1 to 1, that's now on the x-axis. Okay? So, that's a little bit of a difference there. Okay, so what does inverse sine and inverse cosine do? Well, it basically finds the angle which has a given sine value. So for example, if I ask you what sine of 60 is, it's root 3 over 2. Okay? So sine of 60 is root 3 over 2. That's 60 degrees right there. The y value there is root 3 over 2. Now, if I asked you this, inverse sine of root 3 over 2, what I'm asking you for is, what is the angle, right, that intercepts this so that the y value is root 3 over 2? So what angle intercepts at a y value of root 3 over 2? 60 degrees. Your answer will be 60 degrees. Okay? All right. Now, let's summarize this. So, you have y equals inverse sine of x. Okay? Y is always going to represent the angle. So y is the angle. The answer to the inverse sine is always the angle. This x must always be between negative 1 and 1. Okay? So now you're going to have something like this. Y equals inverse sine of x. So when I give you like inverse sine of a number, you have to tell me the angle. But remember how we restricted the domain to only go from negative pi over 2 to pi over 2? Why don't we draw that on a unit circle? Okay? Okay. Where would negative pi over 2 be here? On the bottom here. And pi over 2 would be here. 0 would be here. So we're just going to take this much of it. This other part of the unit circle is going to go away. So we're just going to take 1/2 of it. So what angles are here? Pi over 6, negative pi over 6. Pi over 4, negative pi over 4. Pi over 3, negative pi over 3. How many total angles are those? Is that? It's more than 6. 9 angles. There are 9 total angles, which means if I give you a question, inverse sine of something, your answer can only be one of those 9 angles. So really, if you had to guess, you always have 1 out of 9 chance to get it right if you just put down one of those angles. Okay? Huh? But we're not going to guess. Huh? Okay, so let's do this. Okay, so let's do this. If you go here, okay, like, you know, this is 0, this is pi over 4, negative pi over 4, right? All of those are these angles right here, okay? Now, take a look. Where is 7 pi over 4? In what quadrant?
Quadrant 3.
7 pi over 4, what quadrant is it in?
Quadrant 3.
No, but in a regular unit circle, 7 pi over 4, is it 3?
Yeah.
It's in quadrant 4.
7 pi over 4 is almost 2 pi.
You can only go up to 9.
Oh, Zoe's right. Yeah, it's quadrant 4.
In a regular unit circle, what quadrant would 7 pi over 4 be in? Quadrant 4. Okay, so here, quadrant 4. However, is 7 pi over 4 in this restricted range? No. 7 pi over 4 is all the way over here. So it's unusable when we're doing inverse sine. Okay? All right. So, if this x inside is positive, the answer should be in quadrant 1. If it's negative, it's in quadrant 4.
So it can never be.
So now, let's do one example here. Inverse sine of root 2 over 2. So basically what we want is the angle for which sine is root 2 over 2. Okay? So sine is the y value, right? So y value root 2 over 2. What angle? Pi over 4, right? We want to do these in radian. So what angle intercepts the unit circle at a y value of root 2 over 2? That's pi over 4 radian. Did I say degrees or radian before? Yeah, we're going to do radian.
Oh, so the y is the degrees. Or the radian.
Right.
Can you just like shorthand realize that if it's positive and it's
Yeah.
okay.
Okay, so inverse sine of negative root 3 over 2. So now we want the angle for which the y value is negative root 3 over 2, right? So for what angle is sine negative root 3 over 2? It's negative pi over 3. Okay? So here, sine is the y value. We want the y value, we want it to intercept at a point where the y value is negative root 3 over 2. Okay? So that means you have to go down root 3 over 2. For what angle are you going down root 3 over 2? That's negative pi over 3. Okay? Arc sine of negative 1. Here again, we want the y value to be negative 1. For what angle should you go down to negative 1? Negative pi over 2. Okay? If you want your y value to be negative 1, you're going to be right over there. Now, you shouldn't really have to draw these every single time, but if you want to, you're more than welcome to. Okay? Okay, so that is about the sine. Now for the cosine, it's the same situation. This is the graph of the cosine. The full thing doesn't pass the horizontal line test, but guess what? If I only take this part, right, that does take the horizontal line test. But now I'm on a different region. I'm going from 0 to pi. Okay? So 0 to pi. It means we're looking at the first and second quadrants. So if you take a look at this, I'm looking at these two quadrants right there. So this is 0, this is pi. Above is pi over 2. My angles are pi over 6, pi over 4, pi over 3, 2 pi over 3, 3 pi over 4, 5 pi over 6. Anything else doesn't exist to us. Okay? So if this x is positive, it's in quadrant 1. If it's negative, it's in quadrant 2. Okay? So if I ask you for, like, cosine of a half, it should be in this quadrant. Cosine of a negative half, it should be in this quadrant. So now let's go over here. Our cosine, negative root 3 over 2. This time, cosine is the x value. So I want the cosine to be negative root 3 over 2. What angle intercepts the circle at a point such that the x value should be negative root 3 over 2? Like you're going over all the way there, right? 5 pi over 6. That's going to be this one because you're going all the way over there, right? So 5 pi over 6. Because at 5 pi over 6, the x value is negative root 3 over 2. You have to go all the way to that side, root 3 over 2. So that would give you 5 pi over 6.
But how did you know you had to go? Like, why couldn't it have been 2 pi?
Because for 2 pi over 3, the cosine value doesn't go root 3 over 2. It only goes a half.
So how do you figure out how far it goes?
Well, that's what we did in section 3, because at pi over 3, the cosine is only a half. But for pi over 6, the cosine is longer, root 3 over 2. Okay, so inverse cosine of 1. I now want my x value to be positive 1, right? If your x value is positive 1, what angle do you land at? 0. You can't say 2 pi because it's not between 0 and pi. You see that? Right? So 2 pi is all the way over here, whereas our function stopped here.
But then why can't the function go take the other segment?
Because math gods agreed on that segment. You want to stay as close to the origin as possible, right? Because it doesn't make sense to go over there.
This is based on 369, right?
And 45. Yes, the special angles. The special.
Okay, got
But
it.
there is also a 0. Okay.
I now understand.
So inverse cosine of negative 2. This is a trick question because I've always said that x must always be between negative 1 and 1. Because negative 2 is not between negative 1 and 1, this is out of domain. So this doesn't work. This doesn't exist. Okay? Just like when I give you, let's say, cosine of an angle, you can never get more than 1. You can never get more than negative 1, right? This is going the opposite. Okay, we never graphed tangent. It's covered in pre-calc honors. But, voila, here's what tangent graph looks like. You really don't need to know how it looks. Just know that the domain is still negative pi over 2 to pi over 2. So it's very similar to sine. Okay, we have 0, pi over 6, negative pi over 6, pi over 4, negative pi over 4, negative pi over 3, pi over 3. How many is that so far? Not 9. 7. So tangent doesn't include the pi over 2 and the negative pi over 2 because tangent has vertical asymptotes there. It's undefined at those points, right? And tangent of pi over 2 is undefined, so we can't. The red ones, the pi over 2 and negative pi over 2. So for tangent, it's, you even have a greater chance. If you just throw out one of these 7 angles, you have 1/7 chance to get it right. Okay? So again, if we're looking for positive, it's in the first quadrant. Negative, it's in the second quadrant. Okay, so remember now, tangent of an angle, right, is its vertical side divided by its horizontal side. So for what angle, right? So vertical and horizontal, those two legs, the ratio of those two legs. For what angle is the tangent equal to 1? So the ratio of the horizontal to the vertical is 1. Pi over 4. Tangent of pi over 4 is 1. Because if you do opposite over adjacent, you get 1. Y over x, you get 1. Okay, arctangent of root 3 over 3. So now we have to figure out for what angle, when I do the y over the x, do I get root 3 over 3? Maybe there's a little bit of a trial and error here for the first one. Yeah.
At pi over 4, isn't x 0?
No. At pi over 4?
Oh, wait.
Okay, so let's take a look at pi over 6.
Oh, I know.
For pi over 6, x is root 3 over 2. Y is 1/2. Now, when I do 1/2 over root 3 over 2, does that give me root 3 over 3? 1 over root 3? No? It does. See, I asked it in a way that misled you. Okay? So, pi over 6. Okay? We're always going to go with radian.
How did you get pi over 6?
Zoe, we have to do y over x. At pi over 6, the y value is 1/2, the x value is this. So 1/2 over root 3 over 2. These two cancel. 1 over root 3, root 3 over 3. Huh?
But nowhere in there is pi over 6.
But what angle gave us that? Yo! But what angle gave us that? That was the pi over 6. So for what angle is the tangent root 3 over 3? For the pi over 6 angle.
I won't.
So next one, we want the tangent to be root 3. So first of all, if you have a tangent and if root 3 shows up in the tangent, can it be the 45, 45, 90?
No.
No, because that's only a root 2. So it's got to be, Okay, so why don't we try the pi over 3? Let's just draw the pi over 3 here. Oh, it's got to be negative, right? Pi over 3. Well, let's see what the pi over 3 looks like. The x is 1/2. The y is what? Negative root 3 over 2. So now if I do y over x, right? 2's cancel. Oh, look, I have negative root 3 over 1. Oh my God, that is so the 1. So that must be the angle. What angle was that? Negative pi over 3.
How do you know?
You have to try something, right? I just ruled out pi over 4. Oh my God. Okay. So far everything we've done here, right? If you want, you can do it in your head. Like, there is no work required. However, you can still show work. Now, let's move on. Let's move on here. Now we have nested functions. So tangent and inverse cosine of 4 over 7. Okay, so what we're going to do here is the following. You have to start from the inside. And you have to draw a triangle that models this situation, a right triangle. So there is a mystery angle here, the cosine of which is 4 over 7. Well, cosine is adjacent over hypotenuse, so the adjacent to theta is 4 and the hypotenuse is 7. Okay, that leaves a missing side. So let's find the missing side. X squared plus 4 squared is equal to 7 squared. So x squared is equal to what? 49 minus 16, what is that? 33. So x is root 33. Is that right? Okay. So now we go back to the outside. Now can I find the tangent of this situation, of this angle theta? I can find the tangent of theta, and it's just root 33 over 4, and I'm done. Okay? These ones are a little bit more straightforward. I mean, the other ones are too. They're just new to you. Yeah. No. Inverse cosine just means find the angle. It doesn't make it a reciprocal. That's secant. Okay? Okay, yes.
So for these ones, you don't actually have to find what inverse cosine of 4
No.
over 7 is.
No. Okay, so here we go. We start from the inside. Draw an angle. The inverse tangent of that angle, inverse tangent of 3 over 8. So the tangent of that angle is 3 over 8. That means opposite over adjacent is 3 over 8. So I need to find x. Okay, so 3 squared plus 8 squared is equal to x squared. 9 plus 64 is x squared. So x is root 73, right? Okay, now, can we find the sine? What is it?
3 root 73 over 7.
Yeah, it's 3 over root 73. So 3 root 73 over 73. Now, take a look at this next one. You have cosine of arc cosine. So cosine and arc cosine undo one another. That means they, just cancel each other out. All you have is negative root 2 over 2. Okay, so that's it. If you have the same thing, you can just cancel them out. The only thing is you have to make sure inside an arc sine or an arc cosine, you have a value that's between negative 1 and 1. So if this was cosine of arc cosine of 2, the whole thing would be undefined. Okay? All right, here we go. This one, sine of inverse tangent of negative 1. Okay, so for this one, you're like, wait a minute. I know what angle gives me tangent of 1. What's the angle? 45 or pi over 4. But if it's negative 1, it would be negative pi over 4. So this would just be sine of negative pi over 4, which is how much these days? Negative root 2 over 2.
How come when you draw a triangle?
Okay? Negative root 2 over 2. You don't have to draw a triangle for this one because it's one of the special angles that you know. All right? Okay.
Press start.